Intelligence, 24th of April 2025. Today we will look at a method called nemawashi. It's a method that I have developed in 2015 in my first doctoral thesis. It's a way to visualize organizational dynamics, make sure you download this paper I copy here. It's free, okay? So you can download the PDF from the website. It's the content of the paper is also relevant for the exam, okay? Especially the concept of alignment. So the word nemawashi is Japanese, means to prepare the ground. Okay? Imagine you have a process, a company, or a department you are dealing with. Imagine it as a tree, as something that is living. Okay? Before you plant a tree, you want to make a hole in the ground and you want to put some good earth. Make sure you have quality earth so that the tree can root properly, okay? So this is the organization. And this is the ground. And with nemawashi you prepare the ground, okay? So with this method, we describe organizational dynamics, we do so by transforming the information contained in the KPIs KPIs are the key performance indicators, in German Kennzahlen, okay? From the management system. So what we have, the hypothesis is that we have a number of KPIs as a function of time. Okay, so we have a list of KPIs as a function of time. Where E is going from 1 to N, are the list of the KPIs, okay? So, for instance, some KPIs could be cost, or could be lead time, or could be return on invest, could be cash flow, anything, okay? So you need to remember that each KPI describes only one part of the variability in the system. So imagine your process or your factory or your department or whatever is like a little sphere, okay? This is the place you're trying to describe. This is your factory, your process. And now we have the controller looking at it. The controller just looks at one part of the whole world, and he says, you need to bring cost down. That's what controllers do. Okay, so they look at it, and for them, the world is lila. Because they look at it from the Euros perspective. And they are right. We need to bring costs down. They are right. But then we have also the guy from logistics, and he looks at the world from the inventory perspective. And for him, the world is green. It's green, right? Yeah. So inventory. Bring inventory down. And the world is green, and he's also right. And then the guy from production, who is coming from other side, and is saying, no, we need to bring productivity up. And for him, the world is rosa. And everybody's right, but everybody's wrong. Okay? So each KPI is only describing one tiny part of the variability in the system. You need to put them together to describe the whole dynamics of the process. Okay? So each KPI is, and in 2 or 3 years, you are going to be leaders. You are going to be the Abteilungsleiter or Gruppenleiter or something. So you need to take into consideration that when you are a leader in an industry, you are surrounded by knives, okay? And if you decide to bring quality up, you're gonna suffer in the cost side. If you decide to bring the cost down, you're gonna suffer in the delivery rate, and so on. So all these knives that you have around will make you blood, okay? Bleed, I guess, bleed. If you are a good manager, you will decide when to bleed and where, but you will bleed no matter what, okay? So keep that in mind, that management is like suffering, okay? It's like doing sadomaso, like every single day you get into the factory. So we measure with each KPI we describe only some portion of the variability. Variability is measured as the variance of a certain KPI. The variance, as you know from the statistic lecture, is this. Okay? Being x the mean value. So this is important because you need to understand what we're talking about. Okay? So let's what is the steps? I guess the best way to learn them steps is to make an example. So now imagine, let's make an example of nemawashi, step by step, and then you can replicate it at home with different numbers. For the exam, make sure you represent all calculations in the exam, please. Because if you don't represent all calculations in the exam, I don't know if you know. Okay? So I know you might put it in your calculator and then just give me the result, but I need to know that you know, and this is the reason, okay? So this is important. A KPI system of a factory is three-dimensional. And has following data. Okay, so we have only 3 dimensions. What happens if we have more dimensions? We learned the week before, last week, we learned how to perform PCA, right? So you can perform PCA to 3 PCs, to 3 principal components, and then do nemawashi. Okay, so you need to put the things together a little bit. Let's say we have quality. We measure quality, Q, like parts per million. This means the number of bad parts for every million parts produced. Then we have the delivery rate. How many deliveries are correct in percentage. And then you have the cost. We measure the cost in euros per unit. These are 3 standard KPIs you will find almost in any factory in the world. Okay, so you have the customer here, the quality, you have the customer here, the delivery rate, the time, the quality, the time, and then you have the cost that makes you live or die. Okay? And then we have so you are the managers of this process, okay? So you have taken this KPI like in 4 or 5 weeks, 5 weeks, and you want to know what are the dynamics of your system. So in calendar week 1, you have 3,300 ppms, meaning that every million parts you produce, 3,300 are bad. You have 91% delivery rate, which means that out of 100 deliveries, 91 come on time. And 17 euros per unit is 17 euros per unit. This is the cost to produce 1 unit. Okay? This is calendar week 1. Calendar week 2, we go down on the quality. So we get better, we still get better in the quality. Here we get worse on the delivery rate, we get better in the cost. In the calendar week 4, we are getting better in the quality, then we're getting better in the delivery rate, we are getting better in the cost. So these bumps are very common, okay? Sometimes you need to get worse to get better. Then you still get better in the quality, you get better in the delivery rate, and then you get worse a little bit in the cost. This is our data set. So in the exam, I would give you this. This is the table that I give you, a list with KPIs, and then ask you, please describe the organizational dynamics with any known method. And you need to use Nemawashi, okay? So the first step, what is one thing you see here in these numbers? What just jumps in your eye? Well, one thing that you should be trained, you should train your eye to see is that the quality here is in the thousands, delivery rate is in the hundreds, cost is in the tenths. You need to train your eye to see that, just on the spot. So one unit of change from 3,300 to 3,301, it's not the same in proportion as 1 unit in change from 17 to 18. This is obvious, right? So we need to, as of now, we cannot compare this data. We need to make something to compare the data. And what we do is we normalize on the time axis. So on every column is normalized so that we can compare them. So the step 1, first step, is to normalize to compare. So each KPI is brought in the range between 0 and 1. Each column. Because right now we have apples, oranges, watermelon, banana, and so on. So different things that we cannot compare. And because we want to compare them, we want to put them all together in one picture, we need to make them comparable. For that, we bring them together in an interval of 0 and 1. So in order to do that, the way to do this is to take the number, whatever number we have, of a series we subtract the minimum value of the series and then divide it by the maximum minus the minimum. If you think about it, this will bring the data set to an interval between 0 and 1. But this is just a theory. Let's continue with the example to see how it works, okay? So make sure you do this at home with different numbers, at least once, okay? Because this will bring you speed, and speed is good for the exam. Let me make a little screenshot here so that I go faster. Okay. So this is the data. So let's normalize the way we saw. The way to do it is to take the KPI, we name it Q star, and then we say the calendar week 1 is going to be like the number 3,300, which is this number, minus the minimum of the series, which is 1,300. Okay, it's the minimum of this series is 1,300. Okay, you see that, right? Divided by the maximum of the series minus the minimum. So this delivers you 1. Okay? So calendar week 2, 2,700 minus the minimum of the series divided by 3,3 minus the minimum. This is 0.7. The calendar week 3 is 1.8 minus 1.3 divided by 3.3 minus 1.3. This delivers 0.25. The next, calendar week 4, 1.5 minus 1.3 divided by 3.3 minus 1.3. And this delivers 0.1. The last one will deliver 0 because it's 1.3 minus 1.3. And this delivers 0. You will notice when you do it, you will always have one number is 1, the maximum, one number is 0, the minimum, right? Any questions? How to do this? This is super simple math, okay? So if you write me in the exam, if you write me only 1, 0, 7, 0, 25, 0, 1, and 0, you get no points. The reason is I need to know that you understand the method, okay? And of course you can come to we had it yesterday, and I understand the reactions, okay? Totally understand it, but please understand me as well. If you come to the exam revision and you say no, but it's correct, I say yeah, I agree, it's correct, but I don't see that you understand it in the paper. Okay? You need to write it down, please. Yeah, I mean, I cannot say it enough times. I will have the same conversation next semester and next semester and next semester, I guess. It just doesn't come through. So the delivery rate, and this is also the reason why I do it in the lecture, okay? I could just copy you the numbers and then just go faster, and I take my time because I want you to understand how we do it, and you need to show that in the exam, okay? So what do I need to write here? So you guys want to do it? Maybe you? Can you tell me what I write now?
Yes, can you maybe zoom not too thick? 95 minus...
No, 91. I need to write 91. The first number. I make the first one,
yes,
you go the next, okay? 91 minus?
89.
89, yeah, the smallest.
Divided by 95.
95 is the biggest number,
Yes,
okay?
minus 89.
89, good. So this delivers 0.33. Next, you want to do it?
91.
No.
93.
Yeah, but you shouldn't look at the solution already.
93 minus 89.
Yeah.
95 minus 89.
95 minus 89. Very good. 0.66. So the next, do you want to do it?
89.
89?
Minus 89.
Yeah.
Divided by 95 minus 89.
Yeah. So this gives you 0 because it's 89 minus 89 is 0. Then the next is, you want to do it?
It's 92
minus 89.
divided by 95 minus 89.
Very good. So this is going to be 0.5. And the last one is easy. 95 minus 95 divided by 95 minus 89. 89. Sorry, minus 89 here. This delivers 1. Okay? You see always 1 0 and 1 1. Yeah, so that's the deal here. And for the cost, give me the first one.
This is 17 or
17, yeah.
17 minus 15
15,
divided by 17 minus
no.
I believe it's
18,
18 minus 17.
no.
I mean minus 15.
Okay, be careful, okay?
Yes.
Okay, so you do the next one again.
18
Yeah, 18,
minus 15
yeah.
and 18 minus 15.
So this goes and delivers 1, very good. I do the rest, 16 minus 15 divided by 18 minus 15. This is 0.33. Then 15 minus 15 divided by 18 minus 15. This is 0. And 16 minus 15 divided by 18 minus 15. This is 0.33. Okay? So we have normalized each column. Each column is between 0 and 1. Meaning, now we can compare each column to each other. Okay? Any questions here or at home? So I hear nothing. So the second step, we need to graphically represent, this is our goal, the organizational dynamics. And we could already do it, okay? We could already do it. But in 3D. And 3D is not very good method to represent graphics. It depends on the perspective, but we could do it. And we could do it like this. It's simple as taking each axis one KPI. So we could say here, this is our quality star, this is our delivery rate star, okay? So you see, we have here a three-dimensional domain. And then we say, okay, well, the first point is 1, 0, 33, 0, 66. Okay, let's represent it. 1, if this is the 1, 1, 1, like triangle, we can say, okay, our KPI is going to be in 3D is going to be on 1 on the Q, 0, 33 on the delivery rate, and 0, 66 in the cost. So this is going to be our point 1, 0, 33, 0, 66. This is our calendar week 1. Okay? Okay, I cannot see shit there, so I'll make it different color. So 1, this is better, right? Yeah. 0, 33, 0, 66. Okay, so this number is 1, 0, 33, 0, 66. This is the calendar week 1 point. Okay, so let's take the next point. 0, 7, 0, 66, 1. Good. 0, 7, somewhere here. 0, 66. And then 1. Higher up. So this is calendar week 2. 0, 7, 0, 66, 1. And we can say that the organization is moving from this position to the next position. And this would be correct, but not for us. Because the fact of the matter is that when we describe the curve that the organization is doing, we are going to have the same question marks as before. We don't know, we cannot understand it, okay? So what we do is we take this representation and project it onto something that we can represent in 2D. So let me represent the 3D axis again. This is the delivery rate. This is the quality. And this is the cost. And now we take each axis, 1, 1, 1, and we project it on a triangle. The triangle is called simplex. This triangle, or this red curve or rosa lila curve that we have there, we're going to project it on a triangle that unites. It's like a plane cutting the three axes on the number 1. Okay, this is important. This triangle is called simplex. Okay, all the points. This is a two-dimensional representation with 3 axes. All the points in the simplex. Let's write it down. Geometric characteristics of the simplex. It's like if you are sitting in the point 111, like a guy is sitting here in the point 111 and is looking down. You will see not the lila curve, he will see something different projected. Some other curve projected on the simplex. Okay? It's a like projection, like a shadow. So the geometric characteristics of the simplex are all points, or we have, is a, like I said before, is a 2D representation of 3 axes. Okay? 2-dimensional, but has 3 axes. And all points, all coordinates of all points add up to 1. Now please pay attention, okay? Do not look at your computer, or let me describe this graphically. What do I mean? So I paint the simplex again here as a triangle. I'll try to make it big. It's easier to understand then. This is our simplex, okay? A little bit irregular, but anyway, it should be Pretty regular triangle. Okay, so this is a special kind of space. Okay, you need to think about it as a origami. You know origami, right? It's a folding paper, like origami. It's like projection on paper. So you have 3 axes. The 3 axes are going to be, let me use this color. This is Q star. Actually, it's going to be Q star star. And then we have one axis describing Q star star that goes from this point to the middle point of the other side. Okay, so like there. And now please pay attention. This line, all the points in this line have a Q value, Q star star value of 0. Okay? This point has a Q star star value of 1. Of course, this point has a Q star star value of 0. Okay, so the line cutting the vertical here this point. Here we have a Q star star value of 0.33, and all lines, all points in this line parallel to this, okay, all points in this line have a Q star star value of 0.33, which means, and this is important, the scala of this axis is not linear. Okay, so this axis here, it doesn't go like 1 centimeter equals 1 unit. It's different, okay, because it's a projection. So the triangle is not perpendicular to our vision. This is for 0.33. So for Q, for the delivery rate, what do we have? Let me use maybe another color. This one. For the delivery rate, we have another axis going this way. Okay. This is the delivery rate. This point has delivery rate star star equal 1. Let me put this somewhere else. Doesn't bother. This point has delivery rate 1. This point has delivery rate star star equal 0. All the points parallel to this line, all the points in this line have actually a delivery rate equal 0. All the points in this line had delivery rate star star equals 0.33. This is because of the dynamics of or the geometry of the triangle, and all the points going through this last line are having delivery rate 1. So for the cost, let's take another color. Can you see the color? A little bit. So for the cost, you have here, this point, you have cost star star equal 1. all the points in this line, no, all the points in this line have cost star star equals 0. And all the points in this line have cost star star equals 0.33. Okay? So we have described the three axes, which are 1, 2, and 3. It's like looking at this triangle from this perspective: 1 axis, 2 axis, 3 axis. And these 3 lines are the projections of this, and this. Okay? It's like looking at it in the space. All right. So this is the simplex. Any questions? Now we're going to learn how to put that in numbers, okay? But the math without understanding is not worth it. Because later on you will have a different problem and you need to understand before you use the math. Okay? So at some point we are going to have here a curve. We're going to have a curve, okay, in which our organization is moving. And this is the result of the Nemawashi process. These are the dynamics of the Nemawashi process. Each point is 1 calendar week. Okay? Make sense? Good. Yeah, then let's put it in numbers, what we want to do. For that, we need this data. We make a screenshot there. So I bring it here. And now we want to have the Q star star numbers. So we go ahead and say Q star star of calendar week 1. We want these 3 numbers to add up to 1. Okay? How do we do it? Well, we take the first 1 and divide it by the sum. 1 plus 0.33 plus 0.66. And for the delivery rate, star star, we say 0.33 divided by 1 plus 0.33 plus 0.66. This goes and delivers 0.5. This delivers 165, and then cost star star 0.66 divided by 1 plus 0.33 plus 0.66 equals 0.33. Okay? If you just write these 3 numbers in the exam, you get no points. It is correct, yes. Do I know you understand? No. So forget it. Okay? Is it clear?
Yes.
Please. Calendar week 2, 0.7 divided by 0.7 plus 0.66 plus 1. This delivers to 29.7. Then I take the second 0.66 divided by 1 plus sorry, 0.7 plus 0.66 plus 1 equal to 28. And 1 divided by 0.7 plus 0.66 plus 1 equals 0.42. Okay? Calendar week 3. Next, 0.25 divided by 0.25 plus 0 plus 0.33 equals 0.43. The next one is 0 because it's just 0 divided by something is 0. The last one is 0.33 divided by 0.25 plus 0 plus 0.33 equals 0.57. Calendar week 4 equals 0.1 divided by 0.1 plus 0.5 plus 0 equal 0.167. Next, 0.5 divided by 0.1 plus 0.5 plus 0 equals 0.833. And the last one is 0. Calendar week 5. It's going to be 0 here, then 1 divided by 0 plus 1 plus 0.33 equals 0.75. And the last one, 0.33 divided by 0 plus 1 plus 0.33 equals 0.25. Okay? So now we have what we need to represent the data in a proper manner. And the question is how we do it. Do I need to do it very pretty in the exam? No, you don't need to do it pretty. You don't need to use a scala and so on. Okay, so you don't. Ich habe Schulterschmerzen. Entschuldigung. You don't need to do it very pretty. You need to do it clear, yes, but not super accurate. Okay. So let's see how to represent this data into our triangle simplex. And it pays off to have a video now because you will see how things unfold and how the picture is created. It's better than just having the PDF and trying to figure out how it is done. Okay, so make sure you take the video when you study and see how it grows. So this is the data again copied, okay, so that we don't have to be scrolling up and down. I just make a triangle again, as big as possible for clarity purposes. Try to make it symmetric somehow, a little bit. This is somehow symmetric, right? Not really 100%, but anyway. So we have here our quality star star. We have here our delivery rate star star. We have here our cost star star. And now please follow me. Stop writing. Just follow with the eyes what is happening, okay? We follow the first. Let's draw the axis, which is somehow something that we need as Stütze, or like to know where we are. Somehow almost correct, okay? So not 100%, but it's pretty decent. So we know that the first point all the 3 points add up to 1, so I just need to take 2. You can take the 2 you want. Okay? So I don't care. Doesn't matter. Let's take the first 2 and we will change. So we know that all the points parallel to, let's say, let me get a different color here. All the points parallel to the line here have a constant Q star star. We know here we have Q star star 0. We have here Q star star 0.33. We have here we have Q star star 1. So between 0.33 and 1, somewhere in the middle, it's my 0.5, right? It's not going to be accurate. So what you paint will not, we will let machines do that later. So you don't need to care about being super accurate. Just be rough, okay? Make sure that you have enough time to do it in the exam. So all the points here in this line have Q star star equals 0.5. Good. So our point in calendar week 1 is going to be on this line. Good. Then let's take the next delivery rate, okay, a different color. And we know that all the points in this line have a constant delivery rate. This is going to be 0, this is going to be 0.33, and all the way down there is going to be 1. So we have 1.65. So somewhere here, we're going to have a constant delivery rate of 0.165. As I said, doesn't need to be accurate. So where these two lines cross is going to be my point, okay? Actually, it should be higher. Let me. It should be around here, somewhere there. Okay. So why do I know it should be there? Because the horizontal is 0.33 on the cost, which is the value we are having, okay? So that's why. But it doesn't matter. You don't need to look at that in the exam, okay? So this is our, I lost one line. This is our point, calendar week 1. Was it understood? This is our calendar week 1 point. Calendar week 1. Any questions? Online, those taking part online? Let's make the second point. So now we want to take, I don't know, quality and cost. Okay? So we know all the points parallel to this line have constant quality. All the points parallel to this line have constant quality. So we have here 0.5, we said. We have here 0.33 at some point. We are looking for 0.297, so it's going to be around here, okay? On the other side to 0.33, between 0.33 and 0, okay? So this is going to be a quality, quality star star 0.297. And then for the cost, I need to take another color, take green, and I need to make a horizontal line. At what stage? 0.42. So it's going to be here? No. This is cost 0, all these points of cost 0. This is all these points of cost 0, 33. This is all points of 1. So it should be somewhere around here, okay? Yeah, somewhere here. So our calendar week 2 point is going to be here. This is our points, all the points of cost star equal 0.42. So do I get points if I paint the points but I don't explain the lines? Well, a bunch of lines, okay? So you need to explain. How do you explain? By putting these descriptions. Okay? So this is calendar week 2. So we know our organization is moving. I want to use a different color. It's moving from this point to this point. And this is the organizational dynamics that we're looking at. Okay? Does it make sense? And we do that for all the points. So whenever we have a 0 in our line, we take it, we use it because this is easy. It's going to be on the edge of the triangle. Okay, so let's take this one and this one, 0.57 and 0 in the delivery rate. So all the points in the delivery rate are going to be all the points in the delivery rate are going to be 0 parallel to this line. Let me take the right one. So parallel to this line, all the points are going to be delivery rate 0. So we're going to take that. This is going to be delivery rate star equals 0. And for the cost, we take parallel to this line, and we say it's going to be 0.57, which is going to be somewhere around here. Okay, so this is cost star 0.57. And our calendar week 3 is going to be right there. So this is our calendar week 3. We represent the dynamic by a little arrow. And this is the way the organization is moving. Next, we have a 0 on the cost. We can take the quality, 1.67, 0.167, sorry, and 0 on the cost. 0 on the cost is going to be the horizontal line. So this is going to be cost 0. Cost star equals 0. And the quality star going to be meine Fresse. $167. This is going to be somewhere around here. 0.167. So this is going to be Q star star 0.167. Cutting to with the edge cost 0, this is going to be the calendar week 4. Okay? Yeah. Please. You have a question?
Yes. Is the 0 point of the quality not on the right side?
What was that?
The quality, but 0 point of the quality is not on the right side of the triangle.
Well, we have a value of 0.167 for the quality.
Okay.
And 0 for the cost.
Yes.
Okay?
I was in the
Yeah, you were in calendar week 5. I thought so. All right, so now this is our movement of the organization. You see a big jump. Big jumps are bad. We don't want big jumps. Big jumps are something we don't want. It's a jump we don't control in the organization, okay? So we don't want big jumps. And then we have calendar week 5, 0 for the quality and 0.25 for the cost. So we go and say, okay, 0.25 in the cost is going to be somewhere around here. Cost star star equals 0.25. And then on the quality, it's just going to be here, the edge right there, because we know it's 0. So this is our movement. And then the equation is solved. Okay? So we have described with a method, we have described graphically how the organizational dynamics are with this methodology. Okay? Now, we need an interpretation. Because you're going to be managers, you need to interpret information very fast. You need to know what this means. Or need to explain to your boss, the factory manager, or somebody in charge what it is that you have done, what it means. Okay? So this is where you need to read the paper I wrote in the beginning. This is a PDF, okay? You need to read it to know what we mean with alignment. And alignment means equilibrium, some sort of stability in the system. A factory, a process in the industry is a difficult, complex thing. Okay, so for I'm a boy, so I'm talking about to the boys. Okay, don't misunderstand. This is just an example. Okay, so that you understand it better. So imagine you have a girlfriend. Okay. The same strategies that helped you gain the girlfriend, like, I don't know, bringing roses or bringing chocolate or taking her to the movies, are not going to be successful 1 year after having the girlfriend, okay? You need to adjust. You need to be attent of the changes in the system to make sure, because some days your girlfriend needs to go out, would like to go out for dinner or for dance. One other day she wants to stay home. One other day she doesn't want to see you. Okay? So it happens. It's a system that changes and you don't know why exactly, but it changes. So this is the same. When you have a business, things are so complex that you don't understand everything. You need to understand how to read the system output and then make decisions accordingly and adjust. Okay? And this is the important takeaway from this concept. It helps you dynamically adjust your strategy. Okay? So the way to understand this is like this. So, or to interpret, let's say interpret. The step number 4 is the management interpretation. At the end of the day, as I said, you're going to be leaders in the organizations you are, so you need a management interpretation. So the system is in alignment. On a time point t sub, let's say, j, if the distance between tj minus 1 minus tj minus 2 minus tj minus 1 is bigger than the distance between tj minus 1 minus tj. This means, this is math, okay? This means if the distances are getting smaller, if this distance is bigger than this distance, then we have alignment. If the distances are getting bigger, we don't have alignment. Okay? Let's put it into an interpretation here. Again, you can do that with your lineal in the exam. The distance between calendar week 1 and calendar week 2, in this case, seems to be smaller, this distance, seems to be smaller than this distance. Right? So distance is increasing, so we don't have alignment in calendar week 3. Distance is increasing. So we do not have alignment in calendar week 3. Okay? So next, calendar week, distance between calendar week 2 and calendar week 3, and distance between calendar week 3 and calendar week 4. Well, it seems that this distance is smaller than this distance, right? So it's way smaller. Distance is increasing. So we do not have alignment in calendar week 4. And then the distance between calendar week 3 and 4 is bigger than calendar week 4 and 5. This is obvious, okay? This distance is bigger than this distance. So distance is decreasing. Is decreasing. So we do have alignment. In calendar week 5. If I ask you to do this exercise and ask you a little sentence, a little word, interpret the results, you need to write this. Okay? I mean, this lecture is like a little, like 10 or 12 units, if you wish. 10 or 12 units, not more. Out of these 10 or 12 units, there are 6 or 5 exercises in the exam, so half of it. The exercises are all done in the lecture, so just need to change the numbers and do some exercise. Okay. Anyway, questions, please. Questions online? Yeah.
So we need at least 3 high studies to make an interpretation about the data.
Yes.
Okay.
Yes. You need to, when you have a girlfriend or a boyfriend, you need 2 or 3 weeks or months to know how he or she reacts to you, right? So you need a little bit of experience. So in order to make an assessment on the dynamics of the organization, you need data, okay? You need some time. Just like with deep learning, you need training, here you need data, okay? So you cannot make an assessment until you have at least 3 periods, okay? The goal, of course, the goal is, if you wish, if you, let's imagine you are a leader of I don't know, a production department, okay? Your goal is to have your organization in a point that is like confined. Because there you know that your quality is going to be like this, your delivery is going to be like this, your manpower is going to be like this, your cost is going to be like this. So there you know what is going on. You have your process under control. Once you have your process under control, you can make it better. Okay? This is your goal, to have a big point there and that the dynamics do not drive you out. What do you do? I was a factory manager. So what did I do when I have one guy who is very successful, has everything in green? What do? I take him 3 guys out. Instead of having 100 people, he has only 97. So he needs to reschedule everything. The line, the shifts, he needs to reschedule everything and try to get again green, but with 3 people down. That's how you manage it, okay? All right, so let's make a little break. After the break, I'll stop the video.